All right, welcome back to section 14.5, Similarity. And we're going to cover these, and the process of these two different methods can be a little confusing, but I will summarize it at the end. So if we know various lengths on one object, then we can determine all the corresponding lengths on the other object if we know that they're similar. So as long as we know at least one of the corresponding lengths, there are two methods using the scale factor that we can use to solve the rest of the triangle. So we're going to look at this problem in two different ways. Suppose an artist creates a scale model of a sculpture. The scale model is 10 inches wide and 20 inches tall. If the actual sculpture is 10 inches wide, how tall will the actual sculpture be? And we're going to learn two different methods. And I'm going to go through them, and they may seem a little bit confusing, and then I will summarize them. So they draw this here, and they label what we've got. And so the scale factor method, and I'm just going to kind of summarize it here. The scale factor method, first we want to find K. We want to find that scale factor, and we're going to use it to determine the missing side lengths. Okay, so let's just watch how this kind of ends up, and then we'll kind of clarify it here. So here we're going to say, all right, as the scale model and actual sculpture are similar, there is some value K from the model to the sculpture such that every length on the actual sculpture is K times as long. Therefore, the width of the actual sculpture is K times 10 because we know that this is the width here and it corresponds there. So K times 10 is equal to 60. And they give us that value there. All right, don't panic because the slide can be a little bit much. I'm just pulling from the book and then we'll clarify it. So we know that K times 10 is equal to 60, but we can solve that. And so we can find out that K is equal to 6. And this idea here is that we could say, okay, how do we get from this, the thing that we know on the bigger one, we know that it's times 6. So our K is equal to 6. And so we can kind of go the other way too, which is we would say, okay, we know that this height is 20 inches. We're going to do the same thing. We're going to multiply it by 6 to get this unknown value. And I think what's most important here is this setup here, is they say, okay, the sculpture width and the model width are related. And so the sculpture height and the model height, so they're looking at width and height, and then they've got the sculpture on top and the model on bottom, and they say, how can we get from one to the other? And the thing about proportions is there's so many true and correct ways to set these up. And so this idea is that in the scale model, we're comparing like quantities. And so some people like to think of it as an external comparison because we're comparing across the parts on different shapes. And so we can say, okay, that we know it's going to be 6 times 120, so it's going to be 120 inches because that is, we're comparing across the different shapes, not within the same shape. So if we were to use the internal factor, so before, remember, we jumped, we said, okay, how is this shape related to that shape? That was our external scale factor. But now we're going to say, okay, how is this related to that? How is it related inside one shape? That's the internal factor. So we would say, okay, how do you get from 10 to 20? Well, that's times 2. So then from 60 to what is also going to be times 2. See how in the scale factor we go outside of the shape, and on the internal we stay within our own shape here. And that's pretty much it. So let's just kind of clarify it again. So our scale factor is we're going to be looking at the different figures. And here we're going to be looking within one figure. And we'll do examples and clear that right up for you. Okay. So Tyler has designed his own flag on a rectangle that is 3 inches tall and 6 inches wide. 3 inches tall and 6 inches wide. Now he wants to draw a larger version of his flag on a rectangle, larger, that is 9 inches tall. How wide should it be? Now they want us to solve it with the scale factor and the internal. So let's start with the scale factor. Remember that the scale factor is when we're comparing across the pieces. So first let's, this is our length. No, this is our width, right? They call it wide and tall. Tall and wide. You call it length and width, it doesn't matter. I'm going to call it tall over wide. And you could have said wide over tall. It doesn't matter. All right, so I'm going to do tall over wide here. So tall over wide is 3 over 6 for our model, and it's going to be tall over wide, 9 over, I'm going to say x. Now the scale factor has us jump. Remember that this is our small, and this is our big. Our scale factor has us jump outside. So how do we get from 3 to 9? Well, we multiply by 3. And how do we get from 6 to x? We're going to do the same thing. So that means x equals 6 times 3, or x equals 18 inches. Let's look at the internal way to do this. I'm still going to do tall to wide, 3 to 6 is equal to 9 to x. But internal has us looking within itself. And you could go up or down, your choice, but I'm going to go down because I want to multiply instead of divide. So that's times 2. 3 times 2 is 6. So here, I'm going to do the same thing, 9 times 2. So x is equal to 9 times 2. X is equal to 18 inches. So that is 2 different ways to solve the same thing using 2 different methods. Link this to a proportion. Here's the proportion, y'all. It's 3 over 6 equals 9 over x. Or you could say 6 over 3 is equal to x over 9. There are lots of different proportions that you can use, depending on how you related it. Let's do another example. Kelsey wants to make a scaled drawing of herself standing straight with her arms down. Okay, Kelsey is so here's Kelsey. She is 4 feet 4 inches tall. Her leg is, so here's her whole body. And her leg, oh, well, maybe I should. Okay, so she's 4 feet 4 inches tall, and her leg is 24 inches long. Okay, so that's her leg, and that's her body. If she wants to make a scale drawing of herself 10 inches tall, so here's little Kelsey, and she's going to be 10 inches tall, how long should her leg be? It's always good to draw a picture, no matter how ugly it is. Let's get this all into inches. Here's 4 feet. 4 feet is 4 times 12 is 48 plus 4. So we're looking at 52 inches, just so we're all in inches. All right, and they want us to use the scale factor and the internal. So let's start with scale factor. And label your first proportion here. So you may think like total to legs. And again, you may do the legs on top. It doesn't matter. Total to legs. So for Kelsey, it is, her total is 52 and her legs are 24. And for her scale, her total is 10 and her legs are, we don't know. So for scale factor, we go outside of ourselves. So we say, okay, how do we get from 52 to 10? Well, I'm going to go over here. I don't know that. 52 times k is equal to 10, right? We don't know, times k. That's our scale factor. So k is actually equal to 10 over 52. So I'm going to multiply this by 10 over 52. So I'm going to multiply this by 10 over 52. So x is equal to 24 times 10 over 52. And I know I could type it in my calculator, or maybe we could do the fractions here, but it's going to be about, when you type it in your calculator, 4.615 inches. All right, let's look at the internal. All right, so I'm still going to do total to legs. So that's 52 to 24 is equal to 10 over x. And now I'm going to go maybe up, right? Times what? Times, I don't know. We'll call this k again. 24 times k is equal to 52. So k is equal to 52 over 24. So that is how much we have to multiply this guy by. So this was times 52 over 24. And so we're going to multiply this by 52. Oh, you know what? All right, this is good. I'm actually not going to re-record this so you can see. Why? I mean, I can do this, 52 over 24. But I would really like to know just what to multiply 10 by, right? So x times 52 over 24 equals 10. So now I have to multiply both sides by 24 over 52, which is fine. I can do it. But I should have, well, and it doesn't matter, right? Whatever you do is fine. There isn't a right way. There's just a more efficient way. It would have been more efficient for me to go down because I could just tell you what to multiply 10 by, and that would be no more work. So I'm going to do that just so you can see. But the other one I'm going to keep on it just so you can see as well. So 52 times what is equal to 24? So k is equal to 24 over 52, which means I'm going to multiply this by 24 over 52. So x is equal to 10 times 24 over 52. Type that into your calculator, and you still get 4.615 inches. And so one proportion here could be 52 over 24 equals 10 over x. And when we come back, we'll continue with this section.